We're going to continue our work with transformations, and today we're going to focus in on dilations. We can have vertical or horizontal or both, meaning that they can impact the x values or the y values or both. The placement of the multiplier dictates if we are impacting our x values or our y values. So this question is asking us what the parent function is. So we have g of x, but it's asking to tell us what f of x is. And f of x is our parent function. So the parent function is going to be x cubed. So that means that anything other than the x cubed is some sort of dilation. In this case, we have a 1/4. So we're looking at the placement. It is on the outside of the parent function. Because it's on the outside, that means it's going to change our y values. We have a vertical because it's changing our y values. That's why it's called vertical. And we call this a compression. And that's because we're going to be multiplying the y values by 1/4. So we're going to start with our table of values for the parent function. So -2, if we plug that into the parent function of x cubed, we get -8. If we plug in -1, we get -1, 0, 1, 1, 2, 8. Then we're going to apply our transformation, which is a vertical compression by 1/4. So I'm going to make another column to the right of the y's. I'm going to take all of those y values and I'm going to multiply them by 1/4. So I have -8 times 1/4, which simplifies to be -2. -1 times 1/4, which is -1/4. 0 times 1/4, which is 0. 1 times 1/4, which is 1/4. And 8 times 1/4, which is 2. Now I'm going to graph my original x's because we don't have any changes, and our new y values. So I have -2, -2, -1, -1/4, 0, 0, 1, 1/4, and 2, 2. Then I'm just going to make the shape of a cubic. Then depending on the question that you're given, you could also be asked to identify domain and range, intercepts, continuity, and behavior. So all of those key characteristics that we've discussed in the past. We're going to do the same thing for this second question. So we're first going to identify our parent function. So our parent function is the square root of x. So the square root sign and the x is part of our parent function. Everything else is some sort of transformation. So the first tip I'm going to give you is we must factor under the radical. And we want to do this to be able to identify our transformations properly. So g of x is equal to -2 x minus 3. Now we can actually read off our transformations. So we have a right by 3, down by 2. These are both translations. We have a negative that is on the inside of the parent function. Anything that's on the inside of the parent function changes our x values. So that means that if our x values are being changed, the name is a reflection in the y-axis. That's what's going to make our x values change. And then the last thing we have is a horizontal compression by 1/2. So it's a compression by 1/2 because we see a 2. And remember, whatever is happening on the inside of the parent function, which is this entire thing, that's the inside, is changing our x's. And our x's, we have the opposite to what we see. So we see a multiplication of 2. So really, it's a multiplication of 1/2. Now we have to put all of these things in our table of values. So here's my table of values for the parent function, which is the square root. Notice that I don't have any negatives because I can't take the square root of a negative. So I'm going to first apply my x's. So I have a negative, that's the reflection. So that's this part. Then I have a horizontal compression by 1/2. And then I have right 3. So I'm going to add 3. So I make one entire expression to do all of those transformations. You can break this up into parts. Just remember, you must do multiplication before addition or subtraction. So just think of your PEMDAS. So if I go through and I plug in a 0, I get negative 1/2 times 0 plus 3. So we get 3. Negative 1/2 times 1 plus 3. Kind of running out of room here. So that's 2.5. And negative 1/2 times 4 plus 3. So that's negative 2 plus 3. And so that's 1. Now I'm going to go and apply my translation, which is down 3. That's the only thing that's impacting our y values, or sorry, down 2. So 0 minus 2 is negative 2. 1 minus 2 is negative 1. 2 minus 2 is 0. So we will graph 3, negative 2, 1, 0, and 2.5, negative 1, and looks something like this. Here's our anchor point.